Today we will solve this simple numerical, and this numerical is available in the FSC second year book. This is example number 11.2. The numerical is two small spheres each having a mass of 0.1 gram are suspended from a point with the help of a thread 20 cm long. We have two small spheres, this is sphere 1 and this is sphere 2. Both of these spheres having the same mass 0.1 gram. So the mass of each sphere is given as 0.1 gram. And these spheres are suspended from point A with the help of this thread. The length of this thread is given as L is equal to 20 centimeter, and 20 centimeter we know is equal to 0.20 meter. Similarly, the mass of these spheres are 0.1 gram, and we know that 0.1 gram is equal to 1 multiplied 10 power minus 4 kilogram. Dividing this 0.1 by 1000, we will get 1 multiplied 10 power minus 4 kilogram. Now both of these spheres are equally charged, and both of them have the same charge because these charges repel each other, and the distance of separation between these two charges is given as 24 centimeter. Converting this 24 centimeter into meter, we will get R is equal to 0.24 meter. Dividing this 24 centimeter by 100, we will get 0.24 meter. Meter is an SI unit. We will determine what is the charge on each sphere. We will determine the charge on sphere 1 and the charge on sphere 2. Now we know that the charge on sphere 1 is equal to the charge on sphere 2. Q1 is equal to Q2. We will denote this Q1 and Q2 with Q, and we will determine the value of this Q. Now for solving this numerical, the first thing we will use the Coulomb's law. According to the Coulomb's law, we know that the force of attraction or repulsion between two charges is given by F is equal to K Q1 Q2 by R square. This K is equal to 1 over 4 pi epsilon naught, and the value of this term K is 9 multiplied 10 power 9. Now the distance of separation between these two charges is given by 0.24 meter. So the radius or the distance of separation between these two charges R is equal to 0.24 meter. Substituting the values for K and R in this equation, and we know Q1 is equal to Q2, so we will have QQ and QQ equal to Q square. Substituting these values, we will get the force F is equal to 9 multiplied 10 power 9 Q square divided by 0.24 square. Now further solving, we will get finally force F is equal to 156.25 multiplied 10 power 9 Q square. This is equation number 1. We will later need this equation to determine the value of Q. Now if we draw a line from this point A to point D, this is point D, to the midpoint of length 0.24, then we will have this length 0.12 meter. This will be 0.12 meter because this length is half of this total length. Now we know this side is hypotenuse, this is the base, and this is the perpendicular. Using Pythagorean theorem, we will determine the value of this length AD. According to Pythagorean theorem, hypotenuse whole square is equal to base square plus perpendicular square. The hypotenuse here is 0.20 meter, while the base is 0.12 meter. substituting the values for hypotenuse and base, and the perpendicular is AD. And solving for this AD, we will get the value of AD is equal to 0.16. Now we have determined the force F is equal to 156.25 multiplied 10 power 9 Q square. This length of this side AD is 0.16 meter. Now consider this sphere or this charge. There are four forces acting on this charge Q or this sphere. Force 1 is the force of repulsion due to this second charge, and the direction of this force is along the positive x-axis. While this force F is balanced by the x component of tension T in this thread. This tension T have two components. One is the x component along this direction, and one is the y component which is along the y-axis. The weight of this sphere is acting downward. The weight of this sphere is equal to mg, and the direction of this mg weight is downward, and this weight of this sphere is balanced by the y component of tension T in the thread. Similarly, the force F is balanced by the x component of tension T. So we have the Ty, the y component of tension T, is equal to T sine theta. Similarly, the x component of tension T is given as Tx is equal to T cos theta. Now this Ty we know is balanced by the weight of this sphere, which is equal to mg. So we have mg is equal to T sine theta. Similarly, this x component of tension T is balanced by the force of repulsion, which is F. So we have F is equal to T cos theta. Now dividing this equation number 1 by equation number 2, we will have mg divided by F is equal to T sine theta divided by T cos of theta. This T tension will cancel with this T, and we will have mg divided by F is equal to sine theta divided by cos theta. And we know that sine theta divided by cos theta is equal to tangent theta. So we have mg divided by F is equal to tangent theta. And we also know that tangent theta is equal to the y component divided by x. The y component is actually the perpendicular and the x is the base. So we know that tangent theta is equal to perpendicular divided by base, or y divided by x. Now here from this triangle we can see that the perpendicular or the y is 0.16. Similarly, the base is given as 0.12. Substituting the values for y and x, dividing this 0.16 by 0.12, we will get 1.33. So we have mg divided by F is equal to 1.33. Now solving this equation for force F, substituting the mass of the sphere, which is given as 1 multiplied 10 power minus 4 kilogram. G is gravity, which is 9.8 meter per second square, and dividing by this 1.33, we will get the value of force F is equal to 7.36 multiplied 10 power minus 4 Newton. Now we have the value of force as F is equal to 7.36 multiplied by 10 power minus 4 Newton. And this was the first equation which we have derived, which was F is equal to 156.25 multiplied 10 power 9 Q square. Substituting the value of this force F in this equation, further simplifying this equation, we will get Q square is equal to F divided by 156.25 multiplied by 10 power 9. Now substitute the value of F. F value is 7.36 multiplied 10 power minus 4 in this equation. We will have Q square is equal to 7.36 multiplied by 10 power minus 4 divided by 156.25 multiplied 10 power 9. Further simplifying and solving, we will get Q square is equal to 4.7 multiplied 10 power minus 15. Now taking under root on both the sides, under root will cancel out with this square, and we will have the value of Q charge is equal to 6.7 multiplied 10 power minus 8 coulombs. And this is the charge on each sphere. The charge on sphere 1 is 6.7 multiplied 10 power minus 8 coulomb. Similarly, the charge on the sphere 2 is also equal to 6.7 multiplied 10 power minus 8 coulombs. Thank you for watching, and don't forget to subscribe easyedu for more videos. Thank you.